Have you ever inserted data into a table and later realized that the data already exists in that table multiple times? And have you ever came across this scenario where an order exists for a customer who even doesn't exist? Well, this is not a SQL problem. This is missing keys and constraint problem. And we are going to learn this concept in this video. Hello everyone. I welcome you all to my YouTube channel, The Code Brat. In our previous video, we learned some theoretical concept of DDL, DML, DCL and TCL. So watch this video till end. You will get to know about all the concepts of keys and constraint that we will later use in our hands-on session. The first part is about identity and relationships. Have you ever heard the word primary key in RDBMS? A primary key is used to uniquely identify each record or row in a table, ensuring data integrity by preventing duplicates and allowing for precise data retrieval, updates, and deletions. A set of rules must be satisfied in order to identify or make a column or attribute a primary key. What are those rules? And those rules are: a primary key can never be null, and primary key cannot have duplicates, and only one primary key is allowed per table. But that doesn't mean that only one column will be used to make primary key. We can combine multiple columns as well to make a primary key. A point to note here is that even if we are using multiple columns, key will only be one, not multiple. And this key will be called composite primary key. Let's take an example to understand this. Suppose we have a table named orders in which order details are stored. In this table, order ID is the primary key. In this table, we can see that all order IDs are unique and no order ID is null or blank. So this column order ID satisfies all rules that a primary key should maintain. Thus, this is the primary key of this order table. Keep in mind that if order ID is the primary key of this table, then no other columns will be the primary key other than this column. Now suppose, instead of keeping order ID as unique, I want all order IDs to be unique for each day. Take a look at this table. Here, order ID is not unique. We can see that order ID 101 is there in 1st Jan, 4th Jan, 8th Jan and 9th Jan. But if you look closely, you will see that it is unique for each day. For 1st Jan 2026, all order IDs are different. Similarly, for 4th Jan, all order IDs are different. In this case, we cannot treat column order ID as primary key. Now this is a problem for me. Why? Because still I want to include the column order ID as a primary key. So what should be done now? As I told earlier, that even if there can be only one primary key in a table, it doesn't mean we cannot have multiple columns in it. So if we combine order ID and order date together, it will be unique. Like if we combine 101 and 2026 0101 and then again 101 2026 0104. So now this is unique, not duplicated, right? Also, order date and order IDs both are never null or blank. So we can have primary key with combination of these two columns. And these columns, like combination of these two columns, are satisfying the rules of primary key. Now this key will be called as composite primary key because it's a combination of multiple columns. Second type of key is called candidate key. Now what is this candidate key? All columns or combination of columns that can uniquely identify a row are called candidate keys. Let's take an example of employee table. Here, employee ID, email and phone numbers are columns that we can consider as candidate keys, because all these columns will be unique. Why? Because no two employees will have the same employee ID or same phone number or same email ID. Out of all these three, one becomes primary key, but other remains unique keys. Please remember that candidate keys are a design concept, not a SQL keyword. Unlike primary key is an actual SQL keyword. Now in this example, we have used a term unique key. So what does unique key mean? Unique key ensures no duplicate values are inserted in a column. But we cannot define a row as unique based on this column itself. Why is it so? Because unlike primary key, unique keys can be null. So if multiple nulls are there in a column, we cannot identify uniqueness of a complete row based on this key itself. Let's look at this employee table again. Employee 103 and 106 did not give their phone numbers, so the phone number column is null for them. However, if you see, every employee has unique phone numbers. It's not duplicated. Since two values are null, we cannot fetch unique IDs based on this column. And unlike candidate key, unique key is actually a SQL keyword. You can pause this video to note down the difference between primary key and unique keys. Another interesting and very important key is foreign key. A foreign key establishes relationship rule between two or more tables. This value must already exist in another table as primary key. I mean to say that if we are establishing a key as foreign key, then that foreign key should exist in another table as a primary key. Let's look at this table. We have a table named orders, in which we have three columns: order ID, order date, and customer ID. For this table, we must have a customer table in which we will get details of all the customers present in this order table. So this is the customer table in which we have details of all customers. Now in an ideal scenario, all orders in the table order must belong to a customer, right? And to ensure this rule or relationship, we have concept or key called as foreign key. In this example, order ID is the primary key of the orders table. Similarly, customer ID is the primary key of the customer table. And customer ID in orders table is a foreign key which references the primary key customer ID of the customer table. This will connect order tables with customer table. And if someone tries to enter a row in order table with an invalid customer ID, which is not present in customer table, it should and it will throw an error. Also, we can put some restrictions so that if someone tries to update or delete any customer ID, details like name or city in customer table, which is foreign key in order table, it should throw error. This will ensure relationship doesn't break between these two tables. This was all about keys and identity. Now let's discuss about relationships between table. First type of relationship is one-to-one. It means one row in table A is related to one and only one row in table B. Suppose we have a table named person in which we have two columns, person ID and name. We have another table named passport having columns passport ID, person ID and passport number. Legally, if you see, one person will and should have only one passport. For example, person ID 1 in person table should have exactly one passport ID in the passport table, right? Also, a passport should belong to only one person. Here, passport number 1 belongs to exactly one person, and that is person ID 1. So, this relationship is one to one from both sides, and this is how ideal marriages should work. One to one relationship is used when extra details are split for security or clarity. Now, second type of relationship is one to many. It means one row in table A can relate to multiple rows in table B. Let's take an example of customer and orders table. Customer table has two columns, customer ID and name. An order table has three columns, order ID, customer ID, and order date. In this scenario, one customer can place many orders. So there are multiple order IDs for the same customer, as you can see in this example. For customer ID 1, there are two orders, that is 101 and 102. But this is not true for vice versa. I mean to say one order ID, let's say 101, cannot belong to multiple customers. This means one to many is true for one side, not both sides. It's unidirectional. And this is the most common relationship in RDBMS, as well as in situationships these days. Third type of relationship is many to one. This is just the reverse view of one to many. Let's take example of customer and order table again. Here we can see that multiple orders can belong to only one customer. As you can see here, order ID 101 and 102 belongs only to Alice. But this is also not true for vice versa, which means multiple customers cannot have the same order. So many to one is also true for from one side, not both sides. It's also unidirectional. And one important point to note is that databases usually implement this many to one relationships using a foreign key. Fourth type of relationship is many to many. It means many rows in table A relate to many rows in table B. Suppose we have a student table and a course table. There is no direct link between these two tables right now, so we cannot connect these two tables directly. So what we can do is we can create a junction or bridge table between these two tables. Now we have this enrollment table that will act as a junction between student and course table. A student can take multiple courses. As you can see, student ID 1 has taken course ID Maths as well as Science. Also, a course can be taken by multiple students. As you can see here is that course ID 10, that is Mathematics, is taken by Alice as well as Bob. So this many is from both sides. So that is why this is many to many. A point to note here is that to establish many to many relationship, we always require a junction table. And the last type of relationship is self-referencing or recursive relationship, which means a table relates to itself or table references itself. Let's take an example of employee table again. Here we have employee ID, name and manager ID. Manager ID of this table is referencing employee ID column of the same table. As you can see that Alice is the manager of Bob as well as Charlie. So this relationship is used for hierarchies like managers, categories, folders, etc. This was all about keys and relationships. Next part is constraints, which is responsible for data quality. In this video, we will just learn the theoretical concepts. We will do hands-on in our next video. So the first constraint is not null. It prevents missing values. When applied on any column, we cannot leave a value as null or blank for that particular column. For example, we would never want phone number of an employee to be empty. So we will add this constraint to that column while creating the table. Second constraint is check. It validates values against a condition. It is applied to a column when we want to prevent invalid business data for that particular column. Uh, for example, we can use this constraint when we want marks of all students equal or greater than 0. Third constraint is default. It assigns a value if nothing is provided. It is used when we want a default value of a column of all rows when no value is inserted explicitly for it. For example, if address column is not given as input, then by default it should be unknown. Another constraints are primary key, foreign key, and unique key. And we have already discussed about these earlier. A point to note here is that constraints can be applied in two ways. First is table level and second is column level. In column level, constraints is applied on a particular column of a table. But in table level, constraints are applied on complete table by using the word constraint. Note that in this method also constraints are applied on columns by specifying the column name. That's the end of this video. We'll see you all in next video in which we will have practical sessions for these concepts. Happy learning!